Hello everyone. In this lecture, we are going to learn about Laplace transform. So let's start with the very basic question. What is Laplace transform? In short, Laplace transform is a technique by which any function can be converted from time domain into complex frequency domain. Suppose there is a function f of t. It's a function of time domain. Using Laplace transform, this function can be converted into a function of complex frequency domain, that is f of s, where s stands for complex frequency. It is also to be noted that both ft and fs, they represent same phenomenon or same event. So they are not representing different events, both of them are representing same event. Next comes the point of how Laplace transform is mathematically defined. Mathematically, Laplace transform is defined with the form of an integral, and for any function ft, Laplace transform is defined as Laplace of ft, which is also denoted as f of s. It is equal to integration minus infinity to plus infinity ft e to the power minus st dt. Let us call it equation number 1. As discussed before, S is the complex frequency and it comprises of two parts, sigma and omega. This sigma, it is called Nipper frequency and it is measured in the units of Nippers per second, and omega, it is the radian frequency and it is measured in radians per second. Therefore, in short, by the help of the integral given by equation 1, Laplace transform of any function is defined. Now let's take one example how we can apply equation 1 in order to find out Laplace transform of any function. For that purpose, we consider the function ut, the unit step function u of t. The function is defined as ut equal to 1 when t is greater than 0 and it is equal to 0 when t is less than 0. Now, using equation 1, we are going to find out Laplace transform of this function. So from equation 1, we can write that Laplace of the function ut, it will be integration minus infinity to plus infinity ut e to the power minus st dt, which can also be written as integration 0 to infinity 1 into e to the power minus st dt. Why we have written this? Because the function becomes 0, the function ut becomes 0 for t less than 0. So essentially the lower limit of the integration will be 0. Now if we keep on evaluating this, then the integration can be evaluated in the following way. It will be e to the power minus st divided by minus s, and the limits will be from t equal to 0 to t equal to infinity. So eventually we will end up with Laplace of ut, that is equal to 1 by s. From this example, one can understand how the basic integral formula of Laplace transform can be used in order to find out the Laplace transform of any function. Next comes the most important question, that is region of convergence. So what is region of convergence? It refers to an area in the complex S plane where the Laplace transform exists. In other words, inside the region of convergence, the value of Laplace transform of any function will be finite. So how one can evaluate the region of convergence? In order to answer to that query, let us take the previous example, that is, let us consider the Laplace transform of the unit step function. As we already know, the Laplace transform of the unit step function, that is 1 by s. Now one can clearly understand that if s equal to 0, then Laplace transform of the unit step function becomes undefined. On the other hand, if s is greater than 0, then Laplace transform of the unit step function becomes finite. So in terms of the region of convergence terminology, one can say that the region of convergence, that is RoC, of the function Laplace of unit step will be real of s greater than 0. That means if this condition is maintained, that real of s greater than 0, then in this region the value of the function will be finite. Let us take another example. Suppose for a particular problem, Laplace transform of a function is given as xs equal to 1 by s minus 2. In this case, the region of convergence will be real of s greater than 2. So I hope with the help of these two examples, I have been able to explain how to calculate the region of convergence. If you end up liking this video, please subscribe to my channel and press the bell icon so that you can get updates on my latest videos. And in the next lecture of this video lecture series, I am going to discuss about properties of the region of convergence. Thank you.